Hi, my name is Paul Pancharyan Stumarang. Today I will describe to you about mobile game development. In this course, you will be able to know the draw calls, colliders, and rigid body of any mobile game method names. And I will highlight to you about the Unity tape functionality. You will be know about how to filter the idea of the games. A match consists of vertices and triangle used to form game objects as skips. For now, think of material as piece of fabric wrapping the game object. A material has features such as a color, pattern, or texture. And sign-in is we will look in more detail at setup later in this course. Note that Unity provides GPU-friendly mode-specific setup. A draw call is made by the CPU to the GPU each time a mesh is to be rendered. There is no difference in time that is taken a GPU to render either one triangles or 1,000 triangles. There is a limit on the number of triangles. Eventually they need to be split into multiple draw calls. As the GPU uses the current material to render the mesh, extra draw calls is required for each new material. The driver overhead cost is incurred for each draw call, so we try to keep a number of draw calls to a minimum. Consequently, you may wish to limit the number of material in a scan if you are suffering from an issue. Because there is no difference in time to render one triangles or 1,000 triangles, it often makes sense for the CPU to combine small meshes and send them to the GPU in a sum draw call. Without any effort from you, Unity does this for you at runtime or dynamically. The left image is the start window, the right image is the profiler. 900 cubes have been batched into those draw calls, with the third draw calls used to set up the material. If you have a pro version of Unity, you can also set up static batching. This combines all images of the same material at the compile time. Static batching will reduce the CPU load but increase the amount of the memory use. Imagine we want to render a bomb and a flower. Typically this would take 4 draw calls. One to set up the bomb texture, one to render the bomb, one to set up the flower texture, and one to render the flower. Unity provides the ability to perform texture as blazing. This allows us to send several textures to the GPU and then select which texture in the atlas we wish to use. For two textures, save one draw calls. For the game object that are a long way from the camera, rasterization will destroy much of the detail of the object despite the complex mesh calculation. So we are wasting CPU and GPU time. Unity Pro provides a level of detail system that allows object meshes to be rendered with the reduced level of detail when viewed from a distance. Yellow is used to simplify mesh. Rasterization also destroys the detail of texture of distant game object in the same way. Bitmapping simplifies the game object's texture when the game object is far away. As multiple textures are used, bitmapping will improve render time at the cost of additional memory. The left of image is the original texture. The middle image is the result of rasterizing in the scan. The right image is the result of rasterization and Unity automatic bitmapping. The second image, the two images of appellation show that the effect of bitmapping on the appellation texture along distant way. In this case, rasterization degree the render such that it can be difficult to see the effect of bitmapping. This is just what we want. We don't want bitmapping to cause any noticeable visual effect. To see the effect of bitmapping, we provide a scan of many objects with the same mixed texture. You should compare the different profiler to convince yourself that bitmapping means that memory is used. For example, compare the texture memory used. You should also convince yourself that bitmapping has reduced the rendering time. Adding a rigid body component to an object is like giving it mass. A ball may be a rigid veggie. It can be affected other object it collides with, and it can be affected by collision with other object. Often, rigid body will be affected by gravity, but then don't have to be. A collider is like a wire kite surrounding a game object, used to detect collision with other object. When car fall onto the racetrack, you want the car to stop falling, but you don't really want the track to move. By assigning the track to the colliders, you can make the track affect other object but not be affected itself. Realistic physics require a lot of complex calculation, so you should avoid adding physics components to a game object if they are not really needed. You should also keep colliders in a simple as possible. Have a look the code of spin and start of the method. The argument to the rotate function is 3D vector with x and y and z coordinates. The cube will be rotated x degree around the x-axis, y degree around the y-axis, and z degree around the z-axis. Factor 3 up multiplied by 10 has y coordinate of 10. This means that in h from update that cube will be rotated by 10 degrees around the y-axis. It would be better you as a game designer to filter their ideas through a K question. I think that's all. Thank you for your attention. Goodbye, cheers.